Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question. The problem is maximize difference. Let's have a read at the problem. Chef has two numbers n and m. He calls a pair of number a and b good if it satisfies the following. A and b are both greater than or equal to 1 and less than or equal to m, whereas the greatest common divisor, that is GCD of a and b, is greater than or equal to n. Now, Chef wants to find a good pair AB such that the value of A minus B is maximized. Now, we have to help Chef to find this value of X. Now, there can be multiple good pairs and we have to just maximize A and B. There can be multiple pairs of A and B. So, it could be that, let's say, A and B is equal to some X number and another AI minus BI. This is another pair. The difference could again be same. So we are free to print any of them. Now the input format is simple. We will have t test cases and for every t line we will have n and m. As we saw the output format, we simply have to print the a and b and the who has the maximum difference. The constraints are that test cases will range from 1 to 1000, n will range from 1 to 10 raised to 5 and m will range from n to 10 raised to 9. Now this is the important part, that m will has to be greater than equal to n and less than equal to 10 raised to 9. So this here is just the constraint, right? Because we do not want to have integer overflow. But this here will act as an important piece in solving this problem. Before we move on to solve the sample cases and understand how the solution will work out, let's understand a few facts about GCD. So GCD stands for greatest common divisor. So let's say we have two numbers, right? Let's say we have 5 and 3. As you can see, both are prime numbers. So what are the numbers that divide 5, right? So it is 1 and 5. For 3, it is 1 and 3. Now what are the common divisors between them? It is only 1, right? Now if I were to take, let's say, 2 and let's say something like 18. So 2 is divisible by 1 and 2. Whereas for 18, it is divisible by 1, 2, then 3, well, not by 4, not by 5, then 6. Is it equal by 7 and 8? No. So 9 by 10? No. Then 11, 12, no. 13, 14, and directly 18. I might have missed some cases, but from this you can see that the greatest common one is actually 2, right? So there are two common divisors, 1 and 2, and the maximum one is 2. So if I were to say the GCD of 2 and 18, so GCD of 2 and 18 will be equal to 2. Now, similarly, as we saw our condition, right, that our GCD has to be, GCD of A and B has to be greater than or equal to n. Now, what does this mean, right? Let's go back here. So our GCD has to be greater than equal to n. And again, we saw that our m will always be greater than or equal to m. Now, we are not concerned about what is the GCD, right? We do not want to maximize or minimize the GCD. We just want to maximize the difference. So it does not matter until our GCD is n, right? So how do you make a GCD same, your desired number for any two pair? So let's say I take my A as, let's say, 10, right? And another number as 30. As you will see, the GCD of this is actually equal to 10. Now you can simply see that since 30 is actually a multiple of 10, right? So what we can do is we can have something like, we can take A as n, whatever our n is, and for B we can make B as some multiple of n. So what will happen is our GCD will be for sure that it will always be greater than or equal to n, right? So this is the first fact. Our first fact is that we will make sure that our GCD is n, right? It is bare minimum n, and it can increase from n to, let's say, what, right? So we are sure that we have to keep our GCD n. So we simply say that a is n, and we can make b some multiple of n. Now we can try different number of n, right? We can try n plus 1. But till where do we go? Now, what happens if we go to, let's say, 2n or 3n, right? It ends up becoming the same thing, right? The common factor is still n. So what we'll do is we can try all the numbers, those are between n to 2n. So what we'll do is we will see, okay, so we start from n and we'll go from 2n, right? Now what will be our b? We know that b should be a multiple of n, right? And the maximum value that we can go, right? The maximum value that a and b can go is m. So now that we have fixed our a to n, our b has to be a multiple of n, right? So we can simply say m divided by n, right? So whatever the maximum number is, we can go there. So let's simply take an example, right? Let's say we have our we are given two number, right? So our n is 10 and m is equal to 89, right? Now, as if we said, we are going to make sure that our n is this same, right? So let's say we take a as 10. So what can be our b? What is the maximum number that is less than equal to m and a multiple of 10? We can simply say, well, m divided by 10. Now, what is m divided by 10? What is the maximum that you can get? So 89 by 10, 8.9, the integer would be 8. So 8 into 10, 80. So we can say our b will be 80. Now, if you check, as we saw previously, right, the GCD will be equal to 10. Now, this was for 10, right? What is the difference? So a minus b would be equal to 10 minus 80, that is 70. Well, this is good. Can we increase n, right? So let's say we try n as 11, right? So we try a as 11. Then what will be our b? So it is 80, sorry, is 89 divided by 11, right? So well, it again goes to converts to 8, right? So again, 8 multiplied by 11, it would be 88. Now, what is 88 minus 11? Well, it is 77. So on and so forth. We can try different number, and whichever gives the max difference, we will keep it, right? So the formula would go something like this. We can say for our a, that will go from n to 2n, right? From n to 2n. Our b will be equal to m divided by a, and again multiplied by a because we want the maximum number, right? Now we can simply say if b minus a is greater than our max, right? Let's say initially max was -1. So if this is the case, we can say that our mx is equal to b minus a, and our answer will hold currently a minus b. And at the end, we simply print a and b.
I hope you understood the problem and the approach to solve it. In case you still have any doubt, you can ask them to our doubt solvers. Let me give you a tour on how you can do so. Move to practice problem section. Once you are there, choose a problem that you want to solve. Let's say you got stuck on this particular problem, that is bidding. Just open the problem, and here you can go to ask a doubt. Then in the bottom left corner, you will see a widget that says ask a doubt. Just click on it. You can say, hey, start a new chat. Once you are there, you can type whichever question that you have. So let's say we want to ask, what are constraints? Right? Just click enter. And one of our doubt solvers will definitely solve your doubt instantly. So whenever you're stuck on a question, that is, you are stuck on a TLE or are not able to get an AC, feel free to ask your doubts to our doubt solvers and you will definitely get an answer.
Let's have a look at the C++ code. So again, I have taken t test cases, and for each test case, I call the function solve. In solve, I have taken n and m, and this is our answer A and answer B, and max, which is currently -1. So as we saw, we will iterate from A as n till a is less than 2 into n. Our b is the max multiple of a that we can get. So m divided by a and again multiplied by a. Now if our b minus a is greater than our max, initially that will be the case, right? So our max will change to b minus a and our answers, which were initially 0 0, will change from a to b. And once we are done with this, we will have our max answer and simply we will print it. So answer A, answer B. And as you can see, I have gotten all ACs here. Let's move to the Python code. The Python code is very similar. I have again done the same thing. I have test cases. For all test cases, I call the function solve. In solve, I take input n and m. Again, I have initialized the same variables. Then from range in n to 2 into n, we make our b as the maximum multiple of a that we can reach while being in the constraint that we are less than equal to m. If b minus a is greater than our current max, which will be the case initially, we will change our max to b minus a and we will assign the values to our answer. And once we are done with the loop, we'll simply print a and b. And as you can see, I have again gotten AC. I hope you understood the problem and the approach and solution code in C++ and Python. See you again in another video. Have a good day.